Good morning, fourth grade. And today's math lesson, we're going to be working on how we can add and subtract fractions. So today's learning target is, I will add fractions using a model. Okay, model could be some kind of visual or picture that represents your thinking. Our success criteria today is that I can add and subtract fractions with the same denominator. All right, so today we're going to be working on both adding and subtracting. These fractions, they're going to have the same denominator, but we're going to be able to try and use a model or some way to visualize how we know our answer. Okay? All right, so we're going to work on some practice problems. So if we were to take a couple different fractions, all having the same denominator, I'm going to just go ahead and start with 1/3. And then I'm going to add actually, I'm going to change that. Third does not leave me with a lot of options. So I'm going to go with 1/5 plus 2/5 plus 4/5. All right, we can add these three fractions because they have like denominators. They have common denominators. Okay, so when we add them up, adding only our numerators, 1 plus 2 is 3, 3 plus 4 is 7. Okay, and our denominator, of course, stays the same. All right, so we have 7/5. That looks like an improper fraction. Yes, it's improper because our numerator is greater than our denominator. So we want to see how we can change that and show our thinking using a model, how I would make that a mixed number. Okay, so going from improper fraction to a mixed number. All right, we are going to have a model. Okay, again, remember that denominator tells me how many total pieces equal one whole. So because I have a denominator of 5, I'm going to partition 4 times. 1, 2, 3, 4. Now, 1, 2, 3, 4, 5, I have my 5 whole parts. So if I have all of them shaded in, that means that's one whole. So I'm going to go ahead and show what 7/5 looks like. Okay, so I need to shade in 7 out of those 5. So here's 1, 2, 3, 4, 5. But I need to shade in 7. So what do? I'm going to create another model, again, that has a denominator of 5. So partitioned 1, 2, 3, 4. Okay, and I still need those 7 shaded pieces. So I have 1, 2, 3, 4, 5 already, 6 and 7. Now that I have all of my parts that equal one whole here, because that's 5 pieces, I have 7 of them shaded in. I'm looking at this visual, and this tells me here that this equals 1, okay, because that gives me a denominator of 5 with a numerator of 5, and 5 on 5 means it's one whole, okay? But this gives me a fraction of how many shaded out of how many possible? 5. So my answer would be 1 and 2/5. So when I add up my 3 fractions with the same denominator, common denominator, it gives me an improper fraction. Not always, but sometimes in this case, yes. But I want to change that to a mixed number where it has both whole number and proper fraction. In order to do that, I need to draw a model that represents a denominator of 5 with 7 parts shaded in. And that gives me that new mixed number of 1 and 2/5. All right, let's go ahead and erase, and we're going to try one more. All right. Let's go ahead and use our 8 plus 4/8 plus 3/8. All right. Again, we have common denominators, so we can add them up. So that means my denominator is going to stay the same. All I have to do is add my numerators. 2 plus 4 is 6. 6 plus 3 is 9. In math, best practice is always checking your work, because in math, when we make a mistake, it's usually something that's made because we either did our work quickly or we're overconfident, or we just didn't go back and check our work. So when we check our work, especially with addition, it's good to do it, but maybe in a different order. So we went left to right. Let's see if we can do it right to left just to check our work. 3 plus 4 is 7. 7 plus 2 is 9. Oh, we're good. Just checking our work. All right, now we need to make a model that shows how we can change this improper fraction into a mixed number. I have a denominator of 8. That tells me how many partitions am I going to have. Yep, 1 less than the denominator. So 1 less than 8 is 7. 1, 2, 3, 4, 5, 6, 7. Ooh, I got lucky that I spaced it out pretty good. All right, now I'm going to shade in how many? 9. 1, 2, 3, 4, 5, 6, 7, 8. I didn't quite shade in 9, so I do need to make another model that represents the denominator of 8. So again, I already have that. I'm going to line it up pretty well. I'm going to make those lines. Again, I know that I'm going to have 7. Just checking my work, I have 8 now parts. Okay, I have 8 here, and I need to shade in again that 9th one. Just the one. There we go. All right, so I know that when I have 8 out of 8, that gives me 1 whole. Okay, when your numerator is the same as your denominator, that will equal 1 whole every time. If these two numbers are the same, it equals 1 whole. Okay. All right, so what does this fraction represent? How many is shaded? Out of how many possible? 8. So looking at these two pieces, and that gives us a total of what? 1 and 1/8. So what that tells me is that 9/8, the improper fraction, can change into a mixed number of 1 and 1/8. Okay. All right, now we're going to do one problem. Actually, no, I think we're good. Actually, I changed that again. We're going to try it again, one that has a word problem. All right, so in our word problem, during our pizza party in class, Edwin ate 3/8 of the pepperoni pizza. Kate ate 2/8 of the cheese pizza. And the teacher ate 6/8 of the veggie pizza. How much pizza did they eat all together? Okay. The question is, how much did they eat all together? Show your thinking using words, numbers, or pictures. Direction tells me this is my action, so this is what I need to do. So what we've been practicing is what we're going to do with this particular one. Okay. So I'm going to add my 3/8 plus my 2/8 plus my 6/8. Ooh, lots of pizza. Okay. And I'm just going to add it up. 3 plus 2 is 5. 5 plus 6 is 11. Again, always just check your work. Go from right to left because you already went left to right. 6 plus 2 is 8. 8 plus 3 is 11. Good. All right, now we're going to go ahead and use our model method. So again, we'll create that model, that rectangular shape. My denominator is 8. How many partitions do I need? 1 less, and that's 7. 1, 2, 3, 4, 5, 6, 7. And I'm shading in how many? 1, 2, 3, 4, 5, 6, 7, 8. Didn't quite get to 11, so that means I do need to make another model. Same size, same 7 partitions. Okay, and I still need to get to 11. Those are my 8, 9, 10, and 11. Now that I have 11 shaded out of 8 total pieces, I'm going to go ahead and know that this equals 1 whole. This represents 3 shaded out of 8 possible. So, show your thinking using words, numbers, or pictures. I could leave it here, but 4th grade standard says I should be able to reuse this information and state it into a sentence. Nice race strategy. All right, so how much pizza did they eat altogether? So my sentence could read, they ate 1 3/8 total pizzas, or pizzas altogether. A couple different ways to say it, okay? All right, so here's what you are going to work on using this information. I'm going to give you some practice problems to work on, and this is what I want you to submit. All right, I'm going to write a few problems down. And again, you are going to do the same thing. You are going to showcase what you know using a model that represents your thinking. Oops. Let's change that to a 6. And one more subtraction. All right, so when you're working on these 4 problems, just make sure you're looking at the operation, okay? And remember, what I need you to do is focusing on that standard, adding fractions and subtracting fractions with the same denominator, and you need to use a model that represents your thinking. Okay, so once again, 3/4 plus 2/4 is what? How do you know? Show your thinking. Number 2, 7/12 minus 1/12. Number 3, 5/6 plus 3/6. And finally, number 4, 5/4 minus 2/4. Okay, make sure you write the problem, show your work. And if you have questions, you know what to do. Happy Monday, happy math. I know you guys got this, but if you have questions, please ask. I will be here all day to help and assist. You got it.